Galván Alcaraz. I am an undergrad student at the Center for Genomic Science in Cuernavaca, Morelos, Mexico. I'm interested in cacti genomics. The cactus family has a lot of adaptation to arid and semi-arid environments, and they can grow up to 15 meters tall, such as this one. But even giant cacti start from a tiny little seedling, whose root stops growing shortly after germination. To investigate more about determinate growth, the root tip transcriptome of Pachycereus pringlei was sequenced and de novo assembled. Pachycereus is a columnar cactus endemic to the Sonoran Desert in Mexico. 3 development stages have been identified, illustrated in panels B to D. The root stops growing once the root tip has differentiated. In all sequenced transcriptomes, there is always a relative high number of assembled transcripts that aren't annotated and do not share homology to transcripts from other species. These orphan transcripts are thus taxonomically restricted, but their biological relevance is still unclear. In Pachycereus pringlei transcriptome, 37% couldn't be annotated, and we are interested in that unknown part of sequences. To investigate the unannotated sequence, we first address whether these transcripts may contain putative open reading frames. Using the coding potential calculator, we separate the transcripts into 4 categories, with the majority of them assigned as non-coding. We also counted the number of codons in transcripts with an open reading frame, being the largest one of 500 codons. Orphan gene expression tend to be less than other genes, and these expressions change in specific conditions, such as development. That's why we compared the abundance of annotated and unannotated transcripts, and we performed an analysis of differential expression across root development stages. Then we wondered if this sequence could be an artifact of the assembly. To verify this, we made a reciprocal best plus to 5 transcriptome of Carnegia gigantea, which is the sister species of Pachycereus pringlei, and we found putative orthologs to most of them. After that, we analyzed the conservation of this transcript in 5 cacti genomes, including Pachycereus pringlei, Carnegia gigantea, Lopocereus scotti, Stenocereus turberi, and Peresce humboldti, where we could observe that at subfamily level, the sequences are well conserved. In conclusion, 37% of the root tip transcriptome of Pachycereus pringlei corresponds to unannotated transcripts, and we hypothesized that these are transcribed from orphan genes. These putative orphan genes have a very low expression level, but are differentially expressed across root development. This suggests that they might be biologically relevant. We found reciprocal best hits of the putative Pachycereus pringlei orphan transcripts in Carnegia gigantea transcriptomes, indicated not only conservation in closely related species, but also that these genes are actively transcribed. This conservation was also found in the genomes of other cactaceae species at the subfamily level, strengthening the hypothesis that these genes may be taxonomically restricted and functionally relevant.